Maxima and minima. The function f is said to have a relative maximum value at C if there exists an open interval containing C on which f is defined such that f of C is greater than f of x for all x in this interval. And the function f is said to have a relative minimum value at C if there exists an open interval containing C on which f is defined such that f of C is less than f of x for all x in this interval. In geometry, we interpret the derivative of a function to be the slope of the tangent line by graphing or plotting the points. But in the maximum and minimum values, graphing the function would take time. To easily find if the function is increasing or decreasing at a certain value, we can use the first derivative of a function with its interval. So, let's say f of x is equal to square root of x plus 3 with the interval -3 and 3. So with this function, we will get the first derivative. F prime of x is equal to x plus 3 raised to 1/2. So 1 over 2 times x plus 3 negative 1/2, or 1 over 2 times x plus 3 raised to 1/2. So this is the first derivative of our function. If we substitute -3 to the function, -3 is one of the interval of this function. So our f prime of is equal to 1 over 2 -3 plus 3 raised to 1/2. If we have this value of the function, we will have an undefined value. This is called the critical values of the function. So -3 is the critical value. We cannot have the maximum or the minimum values if x is equal to -3. Next, we substitute the first derivative of the function with the other interval, which is 3. We have here f prime 1 over 2 3 plus 3 raised to 1/2. 1 over 2 times the square root of 6. So by applying conjugate property, we will have our f of 3 square root of 6 over 12. We have here the value of our function if we substitute 3 to our function. Since we have this value, the square root of 6 over 12, if our interval is 3, we conclude that the maximum value of the function is square root of 6 over 12 at x is equal to 3.
We mentioned above about critical values of a function. That is, if c is a number in the domain of the function f, and if either the first derivative of c is equal to 0, and this function does not exist, then c is called a critical number of function f. So, if we want to show that our function exists, we will find its critical values first. Example, we have example of this function. We have this function f of x is equal to x, the power of 4 over 3 plus 4 x to the power of 1 over 3. Okay? To find the critical values, we find first the first derivative of this. Okay? The derivative of this, we get 4 third x 1 third. Okay. Since in the derivation of exponent, this is the exponent, so we just to subtract -1 for them. Since this is the exponent, 4 third subtract -1 and we get this 1 third. So that's why this is 1 third plus the derivative of this, use the chain rule, 1 third x, same with this 1 third. So we get -2 third. Then arrange first x 1 third plus 4 x to the power of -2 third. We're not finished yet, so we must to factor out the common of this. So since the common of this is 4 third x to the power of -2 thirds, so must to factor out so that this function will become one term. X -2 third x plus 1. Then since this is a negative exponential, so to have this positive, we get we must let this x to the power of -2 third in the denominator. So x 2 third. Okay, and now this is the first derivative of this function. Since we want to find the critical value, we'll find first the numbers that will make our function become 0. Okay. Function become 0 or undefined. Okay. By this function, the first derivative of this function, we let our x is equal to -1. So let our x is equal to -1. Then substitute the value of -1 here in this function. So f of x, the first derivative of x is equal to 4 negative 1 plus 1 over 3 negative 1 2/3. So 4 negative 1 plus 0, negative 1 plus 1 rather, we get this 0. So since this is, okay, 4 times 0 is equals to 0 divided by 3, so this function is equals into 0. Then we find to find the function for this will become undefined. We let our x is equal into 0. So by this function again, so substitute 0, f first derivative of x is equal to 0 plus 1 is equal over 3 the s 2/3. So since this is 4, 0 plus 1 is 1, and since this is 0, so 3 times 0 equals 0, and it will become undefined. Okay, undefined. Now we know how to find the critical values and the maximum and minimum values of our function. Now we can know how to solve applications with regard to problem of maxima and minima. But before that, if you want to graph the function regarding maxima and minima, we will have this kind of graph. Okay. Okay. This kind of graph. This is a maximum point and this one is the minimum point.
Of maxima and minima. Example number 1. A rectangular field having an area of 2,700 square meters is to be enclosed by a fence, and additional fence is to be used to divide the fence down. The cost of the fence down the middle is $12 and $18 per running meter. Find the dimension of the field such that the cost of the fence would be the least. So we wish to find the minimum value that could lessen the cost of the field. We will draw the illustration of the problem that says that there is an additional fence that divides the rectangular field and cost of the longer side. This is 12x. Then this is the dimension is 18x. This is the 18y. It is $y. And now we get the perimeter of the field. Recall the formula of the perimeter of a rectangular and the area of a rectangular. We have P is equal to 2x plus 2y, and the area is equal to A equals x times y. P is equal to 2x plus 2y is equal to 2 the 18x plus 2 times the dimension of y, 18y, plus the 12x. It is equal to 36x plus 36y plus the additional 12x. It is equal to 48x plus 36y. Then we get the area. Area is equal to xy, then dy dx is equal to negative x over y. We substitute the value of dy dx here. Negative 48 is equal to 36 times dy dx. The value of dy dx is equal to negative xy. Substitute the value. 48 is equal to 36 times negative x over y. Now we have the answer of negative 48x is equal to negative 36y. Our A is equal to 2700, and our xy is also 2700. Then and our x is equal to 2700 over y. And now substitute the value of y. Now we substitute the value of x. 48 times 2700 over y is equal to 36y. 48 times 2700 is equal to 129,600 over 36 is equal to 36y squared over 3. We multiply this and this. Now we get the answer is 3600 is equal to y squared. Then we need to square root this to get the squared. Then the answer is y is equal to 60. We now get the value of y. To get the value of y, then we substitute the value of y to get the x. X is equal to 2700 over y. X is equal to 2700. The value of y is 60. It is equals to 45. Now we get the value of x is equal to 45. Then we substitute the value of x and y to get the perimeter. 48 times the value of x is 45 plus 36 times the value of y is equal to 60, and we get the answer of 4,320. Now the perimeter is 4,320. We now have the value of x and y, which is 45 and 60 respectively. We conclude that the width of the field is 60 and its length is 45, so that the area of the cause of the fins will be minimized.
Here's the second example of application of maxima and minima. Here's the problem. Find the dimension of the right circular cylinder of greatest volume that can be inscribed in a right circular cone with a radius of 5 cm and a height of 12 cm. We have here the given the height of the right circular cone is equal to 12 centimeter, and the radius of the right circular cone is equal to 5 centimeter. We let that the height of the right circular cylinder is equal to h centimeter, and the radius of the right circular cylinder is equal to r centimeter. So, we draw the illustration of the problem. We draw a right circular cylinder first, that is described by a right circular cone. Now, we label this the height of the circular cone as a 12 centimeter. And the radius of the cone is 5 centimeter. Then the height of the right circular cylinder is equal to h centimeter, and the radius of a right circular cylinder is r centimeter. So with this illustration, we can create a right triangle. Here's we can illustrate. This right triangle represented as a right circular cone, and we create this small right triangle as the represented of the right circular cylinder. So we all know that the height of the right circular cone is 12 centimeter, and the radius of the right circular cone is 5 centimeter, so that we can illustrate the problem. Then here the height of the cylinder, which is h centimeter, and the radius of the right cylinder is r centimeter. Since it is found that this is the small triangle and this is the biggest triangle, so we can create here the height of the small triangle, which is 12 minus h. So recall the formula of the volume of the right circular cylinder is equal to volume of right circular cylinder is equal to pi r squared height, which is this formula. We call this as the equation number 1. And now from this illustration, we can create this by similar triangle. Can create that this biggest triangle is equal to or correspond to the smallest triangle. So we have here the first we can the smallest right triangle, which is the opposite over adjacent, which is 12 minus h over r centimeter is equal to, next is the biggest triangle, which is the opposite over the adjacent, 12 over 5. This is represented as the equation number 2. Since we need to find the height of this equation, so by multiplicative inverse, we multiply both sides by r, so that r times 12 minus h divided by the r centimeter is equal to 12 minus h, equal to 12 divided by 5 times r is equal to 12r over 5. Since it is not really the simplified, so we need to simplify it. So multiply by addition property of equality, so we add negative 12 in both sides. So negative 12 plus 12 minus h is equal to 12r over 5 plus negative 12. So we have here the continuation. So from here, so negative 12 plus 12 is equal to 0. So the remaining is negative h here is equal to 12r over 5 minus 12. So since it is not really the simplified, so we need to simplify it, then we need to multiply both sides by negative 1 so that we can create a positive h. Negative 1 times negative h is equal to h is equal to, then this distributive property, we have here negative 12r over 5 plus 12. So we need to get here the denominator, the common denominator, which is 5. H is equal to, here the 5, the common denominator. So 5 divided by 5 is equal to 1 times negative 12r is equal to negative 12r. Then since this denominator 1, so 5 divided by 1 is equal to 5 times 12 is equal to 60. So with this we can create, we need to arrange this as like this: 60 minus 12r over 5. So this is the equation number 3. Substitute the equation number 1 into equation number 3. How to do that? So we have the formula of the volume of the cylinder is equal to pi r squared height. So we get the height. We need to substitute this height in this formula, in this equation. So we have here the volume of the right cylinder equal to pi r squared height, which is the height is 60 minus 12r over 5. So by the distributive property, so we need to distribute this r squared in this equation. So we have here is equal to pi 60r squared minus 12r cubed over 5. Then so we need to get there the common factor, which is the 12. So pi times 12 fifth, 12 over 5 times this will be simplified as 5r squared minus r cubed. We need to get the common factor of this so that we can create a 12 over 5 pi times 5r squared minus r cubed. So this is the volume of our right circular cylinder. Since we wish to find the radius and the height, and the radius of our cylinder should not exceed with the radius of the cone, we will have our interval as from the first derivative. So we need to find here the equation number 4, the first derivative. So we have here, with respect to the radius, dv over dr is equal to 12 over 5 pi times 5r squared minus r cubed. So with this we need to have here dv dt, dv dr. So the derivative of this equation is 0 from the constant times 5r squared minus r cubed plus, need to find the derivative of this. So 12 over 5, this, just copy onto this. So derivative of this is 5, the chain rule, which is here the 2 times 5 equals to 10r minus 3r, the same with this. So we create here dv dr is equal to 0 times 5r squared minus r cubed is equal to 0 plus this, copy only, 12 fifth over pi times 10r minus 3r squared. So sorry, this is r squared. So we have here dvdr is equal to 12 over 5 pi times 10r minus 3r squared. So let this dvdr is equal to 0. So 0 is equal to 12 over 5 pi times 10r minus 3r squared. So by it multiplied by multiplicative inverse, so we have here 5 over 12 pi times both sides. 5 over 12 pi. So 5 over 12 pi times 0 is equal to 0. Then which this is 12 over 5 pi times 5 over 12 pi is equal to 1. So we get this 10r, this equation only. 10r minus 3r squared. So we need to find the r. We need to find their common, which is the r. So we have here 10 minus 3r. So with this we need to multiply with this multiplicative inverse, which is 1 over r times 1 over r with this. So 1 over r times 0 is equal to 0. So r, this would be removed as 1. So get the 10 minus 3r. So with this we need to find the r. So here times plus negative positive r, 3r both sides, plus 3r. So 3r plus 0 is equal to 3r. So 10. So here 10 minus 3r plus 3r. Negative 3r plus 3r is equal to 0. So we have here 3r is equal to 10. So with this we need to find the r. To simplify the r, we need to have a multiplicative inverse of r, 1r, 1/3 rather. So 1/3. So 1/3 times 3r is equal to 1r. So r is equal to 10 times 1/3 is equal to 10 over 3. So we have here the radius 10 over 3. Since we let that the derivative of the fourth equation 0, so r is equal to 0. So with this radius, we need to substitute this with our previous equation with the height, which is our height is equal to 60 minus 12r over 5. So to find the value of height, we need to substitute the r with this problem. So first, this h is equal to 60 minus 12 times 0 over 5. So our height is equal to 60 minus 0. 12 minus 0 is 0 over 5. So h is equal to 60 minus 0 is equal to 60 over 5. 60 divided by 5 is equal to 12. So our height is 12 when r is equal to 0. Then we have here the 10/3, the r 10/3. So we substitute the height is equal to 60 minus 12r over 5. We have here height is equal to 60 minus 12 times 10 over 3. Substitute on the, since we get the height and the radius of the cylinder. So height is equal to 60. So multiply, this would be 12 divided by 3. This would be 1 and this would be 4. So 4 times 10 is equal to 40 divided by 5. So height is equal to 60 minus 40 is equal to 20 over 5. So our height here is equal to 4. Height is equal to 4 when r is equal to 10 over 3. If we have the 0, r is equal to 0, for our volume, so we need to substitute the volume. So from the first equation, volume of the right circular cylinder is equal to pi r squared height. So we need to substitute the r here, the first two, the r is equal to 0 and the height is equal to 12. So here go. So volume of cylinder is equal to pi r squared height. So our value of r height is 12 and our value of r is equal to 0. So let's substitute it. Pi r squared, or r is 0 squared times height is 12. So pi times 0, since it is squared, so 0 times 12. So we have here the volume. So 0 times 12 is equal to 0 times pi is equal to 0. So we don't have any volume. So when this is the height is equal to 12 and r is equal to 0, which is that. So need to show this. H is equal to 4 and r is equal to 10/3 to get the maximum and the minimum. So volume of the right circular cylinder is equal to pi r squared height. So substitute only. Pi times r is 10/3 squared times height is 4. So pi 10. So 10 times 10 is equal to 100. 3 times 3 equals to 9 times 4. So 100 times 4 is to pi 400 over 9. So our volume here is 400 over 9 pi. Volume of a right circular. So therefore the absolute maximum value for our V is 400 over 9 pi. So this would be the volume, and our height of the problem given, find the dimension of the right circular cylinder of greatest volume that can be inscribed in a right circular cone with a radius of 5 cm and a height of 12 cm. Now the dimension of our right circular cylinder is height is equal to 4 and radius is equal to 10 over 3. So this is our answer.